And we're back here at Water Studios. Okay, this is part 2 of Unit Circle. Okay, so this is the blank picture, which I hope you printed out and put in front of you. Okay, and we're going to work through parts of this unit circle. This picture is going to actually end up being pretty crowded. Okay, by the time we get to the end of it here. Okay, and I might even actually end up using 2 copies of it, or at least another sort of handwritten copy of this thing to make sure it's not too confusing. Okay, but anyway, so what this represents, what this picture has in front of you, this is our unit circle that I described in a previous video. And remember, it has, this is the origin here, that's 0, 0. This is the x-axis. This is the y-axis. And it's x squared plus y squared is equal to 1. So this is, it's the radius 1 all the way around. Now, I haven't put in the rest of the xy plane out there because it's not going to concern us on here. We're just going to be concerned about the part that just goes out to 1 comma 0 here. This is 0 1 here. This is negative 1 comma 0 is that point right there, and then this point right here, y, this is 0 negative 1, like that, right? Okay, so and you've got some other points here, some like lines marked out, and you'll see what those are for. Remember also that the radius of this is 1. So this is 1, this is 1, this is 1, this is 1. It's 1 all the way around, right? Okay, so now what we're gonna do first is we are going to name some of the other points that are on the circle. In this video here, we're just going to work out what some of the other points are that are on the circle, right? Then once we've worked out what some of those xy coordinate points are, besides the negative 1, 0, the 0, negative 1, in the next video, part 3, we're going to put those, we're going to work out what the angles are, what the corresponding angles are, all right, both in degrees and in radians, right? And then we'll see what the points on the circle and the angles have to do with each other. Okay? Okay, so let's see here. We see here that let's pretend that this angle right here, this one, in fact it is. I'm going to make it in red. Sorry for my arm there. This angle right here that's associated with that point on the angle right there. As it happens, that is 45 degrees, okay? This one right here is 30, and that one there is 60 degrees. So this is going to be 30 degrees, and this one here, that one is 60 degrees, right here, like that, okay? This is, of course, a right angle 90 degrees. This is 30 degrees more from 90, so this is 120, okay? This is 30 degrees more than that, so this is 150 degrees. This one right in between is 135, right? Okay? This angle is what in geometry you call the straight angle, 180 degrees. From all the way around like that. If we go 30 more degrees, this one is 210, right? If we go 30 more degrees to there, that one is 240, right? And it turns out that just like we've got an angle in between, this one in between right there is 225, okay? This angle here is 270. Okay? And then we go 30 more degrees, and this is going to be 30 more degrees makes this angle here all the way around like this, you understand. That angle right there is 300. This one to here is another 30 degrees. That's 330 degrees to there, right? In between is 315 degrees, and you can see if we all go all the way around another 30 degrees up to here, that's going to be 360 degrees. Now, this point, this angle here, if we associate it with an angle, this point here can be either 0 degrees, where we don't go anywhere, we just stay right on the axis, or we go all the way around the circle and we come back. That's 360 degrees. That is the same point, right? Okay, more about that later. But what we want to concern ourselves with here is this point right there. Okay, that XY point. What is that point? Now remember, since the formula of this circle is x squared plus y squared equals to 1, every point on this circle has to have an xy, an x value, and a y value, an x coordinate and y coordinate that makes this equation true. So what is that? Okay, well, I'm going to go ahead and so what is this one? We know that this one is 1, 0. So let's try that. 1 squared plus 0 squared, yeah, that's equal to 1. Or this one here, 0 plus 1 squared, well, yeah, that's equal to 1. Or this one here, negative 1 squared plus 0. Negative 1 squared is 1 plus 0 is 1. And in this one here, 0 squared plus negative 1 squared, yeah, negative 1 squared still equal to 1. So these coordinates here make this equation true. Whatever the x and the y values are, have to make it true. So this one does too. But how do we know what they are, right? Well, that's actually not so, that's not that hard. Some of these points we can get just from using a little bit of geometry. Now remember that this point here was associated with 45 degrees. So you can see that. I'm going to mark it here. Inside of this, didn't draw that very well, but inside of this unit circle, you can see there's a right triangle, right? That has an angle of 45 degrees here. Now remember that the angles of this triangle must add up to 90. So if this one's 45 and that one's 90, then of course that angle up there is also 45 degrees, right? Now that's what in geometry you learn to call an isosceles triangle. So these two, so this side length and that side length have to be equal to each other. So actually, and this is an interesting note here, this side length has to be whatever that x coordinate is. That's very important. Okay, and this side length on the triangle here has to be whatever the y coordinate is, because that's how high it is on the y-axis, right? Okay, and those have to be equal to each other. So actually, for this one point on the unit circle, the x and the y value are the same, right? And so we would say that here, x squared plus y squared for that particular point, since this 45, 45, 90 triangle is isosceles, and the x and the y are equal to each other, we can say, okay, for this point right there, I'll write it over here, x is equal to y. So instead of x squared plus y squared, we can write it x squared plus x squared equal to 1. I'm going to put the x where there is a y there, and we can solve for x. That's 2x squared equal to 1, right? Divide by 2, x squared is equal to 1/2, right? So far so good, I hope so. And then we're going to square root both sides to get the x by itself, right? And we get x is equal to, right like that, I guess I'll put it down here. X is equal to positive or negative square root of 1/2. Now it turns out that if that's equal to 1 over rad 2, right? Because the square root of, we'll square root the top and the bottom separately. So the square root of 1 is 1. That's rad 2. We're going to rationalize it by multiplying the top and the bottom by rad 2. And that's going to give us rad 2 over 2. Okay, the rationalized version of that, which is just about, if you do that on your calculator, about 0.71. We're going to leave it in its exact radical form, though. Okay, so this x coordinate here has to be rad 2 over 2. And since they're equal to each other, the y coordinate is rad 2 over 2. Okay, so this is rad 2 over 2, rad 2 over 2. Now how do we know? Now notice it's plus or minus, right? Well, how do we know that it's the plus version? Well, because of course over here the x coordinate is positive and the y coordinate is positive because they're up here in the first quadrant. And so therefore it's rad 2, positive rad 2, and positive rad 2. So that's what that xy coordinate is there. Okay, does that make sense? Okay. Now, using a 30, 60, 90 triangle the same way, and the ratios that you learned in the 30, 60, 90 triangle, which I won't go into here, it turns out that this point that's associated with the 30-degree angle, I'm going to make this one green. This is a 30, 60, 90 triangle. Here again is the y, the length of this triangle is the y coordinate. The length of this side is the x coordinate up here. So if we could use a 30, 60, 90 triangle to figure out that those two coordinates have to be rad 3 over 2, comma 1/2. And I won't go, it's the same kind of analysis we did here with the rad 2, with the 45, 45, 90 triangle, but using the side ratios that you learned about for 30, 60, 90 triangles in geometry. I'm going to skip that part. Okay, so it turns out though that that is rad 3 over 2, 1/2. And then lastly, I'm going to put this in, let's say glorious turquoise here, or whatever this color is. There's another one up here. Hope this is not getting too busy for you. Which, if this is 60, this has to be 30. Also a 30, 60, 90 triangle like this one, just this is 30, that has to be 60 degrees there. So if this is 60 degrees here, then that has to be 30 up here, right? So this xy coordinate up here is going to be, as it turns out, 1/2 rad 3 over 2. Now, does that really work inside of our triangle, inside of our circle? Remember, it's supposed to be x squared plus y squared equals to 1, right? Well, okay, let's think about that. Let's put 1/2 and rad 3 over 2 in there. So that's going to be 1/2 quantity squared for the x plus rad 3 over 2 quantity squared for the y, right? Should have left you more room. Should have left more room here on this. But 1/2 squared is 1/4, right? Rad 3 over 2 squared is 3 over 4. Oh yeah, that's equal to 1, all right. Okay, now notice we've got these other angles here marked out already. And notice, so we've got coordinates here. And then the coordinates that go with 30 degrees, that's rad 3 over 2, 1/2. The coordinates that go with 45 degrees are rad 2 over 2, comma, rad 2 over 2, right? And then up here, the coordinates that go with 60 degrees are 1/2, comma, rad 3 over 2. And the coordinates that go with 90 degrees are just the super easy ones of 0, 1. Now you're thinking, oh my God, Mr. Waters, it's going to take us forever to figure out what all those other angles are. But maybe if you're really looking, you'll see that that's not really true. We actually know what they are. They're all these same numbers here, just versions of these because of the symmetry of the circle. Can you see, for instance, that this, let's say we'll do this one here. I'm going to make a right triangle over here. you can see that by symmetry, this angle here is really 45 degrees. Although we're measuring inside this triangle here, although we're always going to measure the angle over here from 0. But my point is you can see that for this point here, the y-coordinate is the same because it's the same distance up. So the y-coordinate is also rad 2 over 2, and the x-coordinate is the same distance in the negative x direction. So its coordinates are negative rad 2 over 2, comma rad 2 over 2, and that's the point, you understand, that's associated with 135 degrees. This angle right here. Okay? This one here is across from where the 60-degree angle is. Again, the y-coordinate is 1/2, the rad 3 over 2. But you can see that the x-coordinate has to be the opposite because it's the same direction here in the negative direction. So it's going to be negative 1/2, rad 3 over 2, right? And then this one over here is going to be negative rad 3 over 2, again, comma 1/2. So these y-coordinates are all the same, and the x-coordinates are the opposite to each other. Okay? Now down here, it's going to work out the same way. This 210-degree angle, which was over here, you can see that's going to be... Actually, we'll do this one here first. The 225 one, that's the same distance down that 135 and 45 are up. And it's the same distance in the negative direction that 45 was in the positive direction, and the same distance in the negative direction that 135 was. So its coordinates are negative rad 2 over 2, negative rad 2 over 2. And this guy over here, which is 315, this is going to be rad 2 over 2, comma, negative rad 2 over 2. Again, we're just using the symmetry of the circle. Now you can go, okay, I already know what all the other ones are now, too. This one here has to be the same x-coordinate as this, right? Negative rad 3 over 2, plus it's the same distance down that one is up. So this one is going to be negative rad 3 over 2, negative 1/2. This one is going to be negative 1/2, negative rad 3 over 2. And notice that in the third quadrant here, better slide that over there. Sorry, there, now you can see it. I'm going to zoom out a little bit at this point, because maybe you're having trouble seeing that a little bit. There it is. Okay. So those are the coordinates there. This is, I'll make that more neater, negative rad 3 over 2 like that, right? This is 0, 1, that's, or 0, negative 1, that's 0, negative 1. So this point that's associated with this angle that goes all the way around to 240 here is negative 1/2, negative rad 3 over 2. This is 0, negative 1. This one right here is the same x distance as 60 degrees, so it's going to be 1/2, and it's going to be the same y distance but down, so it's negative rad 3 over 2. This one is negative, oh, we already wrote that one in, didn't we? Rad 2 over 2, negative rad 2 over 2, and then this last one here, same x distance, rad 3 over 2, negative 1/2, because it's down, right? Okay, so those are the coordinates that go with some of the circles, some of the points on the circle. Now, this is very important. Any point on the circle, not just the ones we've calculated specifically here, but any point on the circle has an x and a y that will make that equation true. So any angle that we designate here, 80 degrees or 110 degrees or, 245.78 degrees, any one of them will have that we're going to measure from around here, starting at our 0 line here, they're going to have a point on the circle and therefore an XY coordinate associated with it. Okay? That's very important. Okay, so now I think I've put enough on this version of the unit circle here. Once we get, what we're going to do is on the next video, I'm going to have a blank one. I'm going to have these coordinates written in, and we're going to have the angles here, but it'll be a little less busy. We're going to have a radian angles added into to go along with the units, with the degrees. Okay, and then we'll talk about how all of this is going to get us our sine, cosine, and tangent function. Okay, very good. So I'm going to stop this video now, and I hope you're doing this on your own blank copy of the unit circle so that you've got one for you to work with. Okay, and it might actually even be good to print out more than one copy. All right, very good.